Inter-networking devices are products used to connect networks. As computer networks grow in size and complexity, the interconnecting devices used to connect them. First, they allow a greater number of nodes to be connected to the network. Second, they extend the distance over. The purpose of having internetworking device is first, they allow a greater number of nodes to be connected to their network. Second, they extend the distance over which a network can extend. Third, they localize traffic on their network. Fourth, they can merge existing network. And fifth, they isolate network problems so that they can be diagnosed more easily. Local area networks are designed to operate within a limited geographic area, allow multi-access to high bandwidth media, control the network privately under local administration, provide full-time connectivity to local service, connect physically adjacent devices. Wide area networks are designed to operate over geography of telecommunications carrier, allow access over serial interface operating at lower speed, allow access over serial interface operating at lower speed, control the network subject to regulated public service. Control the network subjected to regular public service, provide full-time and part-time connectivity, and connect device separated over wide, even global areas. One interconnecting network device operates at the physical layer of OSI model. A repeater can provide a simple solution if either firstly, when signals first leave a transmitting station, they are clean. If either of these two problems exists, when signals first leave a transmitting station, they are clean and easily recognizable. However, the longer the cable length, the weaker and more deteriorated the signals become as they pass along the networking media. When signals first leave a transmitting station, they are clean and easily recognizable. The longer the cable length, the weaker and more deteriorated the signals becomes to pass along the networking media. So physical media and repeater. Hub is multi-port repeaters are often called hub. Hubs are very common internetworking device. Generally speaking, the term hub is used instead of repeater when referring to the device that serves as the center of the star topology network. Devices that serve as the center of the star topology network, sometimes referred to as multi-port repeater, or in Ethernet a concentrator, not intelligent. Devices that serve as the center of a star topology network, sometimes referred to as a multi-port repeater, or in Ethernet a concentrator, not intelligent. Ethernet is a concentrator. The disadvantage associated with using a repeater is firstly, it can filter network traffic. Data, sometimes referred to as bits, arrive at one port of repeater gets sent out on other ports. And second, data gets passed along by repeater to all other LAN segments of the network, regardless of whether it needs to go there or not. One problem could occur as a result of too much traffic on our network. Firstly, if segments of a network are only connected by non-filtering devices such as repeaters, this can result in more than one user trying to send data on the network at the same time. Secondly, if more than one node attempts to transmit at the same time, a collision will occur. When a collision occurs, the data from each device impact and are damaged. So this is the problem of too much traffic on a network. Disadvantage using repeater is it can't filter network traffic, so data gets passed along by repeater to all other LAN segments. One way to solve problem of too much traffic and too many collisions is to use an internetworking device called bridge. A bridge eliminates unnecessary traffic and minimizes the chance of collisions occurring on a network by dividing it into segments. Bridge is a device that connects and parses packets between two network segments. More intelligent than a hub, analyze incoming packets and forwards or drop based on addressing information. Bridge is a device that connects and parses packets between two network segments. More intelligent than a hub, analyze incoming packets and forwards or drop based on addressing information. Bridge is more intelligent than hub. It can analyze incoming packets and forward a drop based on address information. This is first thing. Secondly, it collects and parse packets between two network segments. Secondly, it collects and parse packets between two networking segments. Third, it controls broadcasts to the network. And fourth, it maintains address tables. Different types of bridges, transparent and soft are used primarily in token LANs. More intelligent than the hub, can analyze incoming packets and forward based on address information. Collect and parse packets between two network segments. Control broadcasts to the network, maintains address table. And at one layer of the OSI model do bridge operate is at the data link layer, layer 2, they are not required to examine upper layer information. So, our data packet originates from the computer and destination is another. The packet travels by all nodes. Firstly, the packet travels by all nodes on the network segment. Secondly, the bridge checks its table to determine whether or not to allow the signal to continue to other segments of the network. And thirdly, the packet reaches its final destination and is not broadcast to other segments of the network. Fourth, the packet travels to all nodes on source B network segment. The packet travels to all nodes is the same thing. And then bridges check the routing tables to determine whether in order to allow the signal to continue to other segments of the network, and the data packet reaches its final destination. Although bridges use tables to determine whether or not to forward data to other segments of the network, the types of comparisons and decisions they make are relatively low-level simple ones. Bridges work best where traffic from one segment of a network to other segments is not too great. However, when traffic between network segments becomes too heavy, the bridge can become a bottleneck and actually slow down communication. And it is the MAC address. MAC address addressing schema. The second addressing schema is the IP address. Like MAC address, every IP address is unique. No two IP addresses are ever alike. However, when MAC address are physical address that are actually hard-coded into the NIC card and occur the data link layer. IP addresses are implemented in software and occur the network layer of the OSI model. Software and occur network layer of OSI model. Routers are another type of interconnecting device. This device parses data packets between networks based on network protocol layer 3 information. Routers have the ability to make intelligent decisions as to the best path for delivery of data on the network. Layer 3 functions to find the best path through the internet. Layer 3 functions to find the best path through the internet. Addresses represent the path of media connections. Routing helps contain broadcasts. Addresses represent the path of media connections. Routing helps contain broadcasts, which means reduce unnecessary network traffic. Network address path used by the router, no address specific port or device on the network. The problem of what network problems can routers help resolve? Routers solve firstly the problem of excessive broadcast traffic, and secondly, routers are able to do this because they do not forward broadcast frames unless specifically do so. Network layer addresses represent the path of media connections. Routing helps contain broadcasts. Addresses represent the path of media connections, and routing helps contain broadcasts. Routers differ from bridges in firstly, bridging occurs at the data link layer or layer 2, while routing occurs at the network layer or layer 3 of the OSI model. Second, bridges use physical and MAC address to make data forwarding decisions. Routers use a different addressing schema that occurs at layer 3. Routers are used to connect two or more networks. For routing to be successful, each network must have a unique network number. The router will determine to send the data from network A to network B, but out is part of the IP address.